Okay, so Kishore, let's proceed ahead with your technical snap for thermodynamics and you're going for ISRO, right?
Yes, sir.
Okay, wonderful. So tell me, when you say energy, what do you mean by that?
It's a invisible thing. Like it has some potential to do something.
Okay, how do you classify it?
Sir,
How do you do the classification of energy?
yes, sir. Sir, energy is of type like potential energy, kinetic energy, and heat energy. And
Okay, okay. So Kishore, you were answering that question, right? Classification of
yes, sir.
energy.
Energy
Hmm.
is yes, sir. Actually, the energy is like a stored form of energy, and it's a transient form of energy, sir. Stored form of energy, potential energy, internal energy, and kinetic energy comes under stored form. And a transient form of energy, we can say like work and heat are a transient form of energy.
Hmm. So what difference do you find between heat and work? These energies. What is the difference between the two?
Sir, heat is due to only due to the temperature, and work can be due to many other things like pressure.
Can you give some example of heat energy and work?
Sir, in a piston cylinder, if we heat the piston, it's form of a heat energy, and the piston movement is a form of work energy.
Hmm. But can heat energy flow if there is no temperature difference?
No, sir, it's not possible.
Are you sure? So if I'm boiling water at constant temperature
Okay,
100
sir.
degrees centigrade, how the heat interaction is taking place?
The water boiling at 100 degrees Celsius.
Yeah.
Sir, whatever energy we supplied, it helps to break the intermolecular force between the molecules.
Mm-hmm.
Heat energy we supplied, it will break the intermolecular bond between the molecules so that the temperature won't get rise.
Mm. Okay. When we say sensible heating and latent heating, what is the difference between the two?
Sir, sensible heating is we are heating it and there won't be any phase change. In a latent heat, whatever energy we give, it will help for the phase change. If we
Mm.
boil water at 100 degrees Celsius at atmospheric pressure, if you boil water at atmospheric pressure, 1 to 100 degree, it's a sensible heating. At 100 to at 100 degrees Celsius, whatever we giving the heat is a latent heat
Mm.
to phase change.
What difference do you find between low grade and high grade energies? And how do you
Sir,
classify it? Low
low
grade, high
grade
grade energy.
energies.
Mm.
Sir, low grade energy is like heat. We cannot convert heat completely to a work, sir. High grade energy means we can convert it completely to a low grade energy. Like work is a low high grade energy, we can completely convert work to a heat.
Mm. Mm-hmm. Okay. Can you explain the type of work? What kind of work we have?
Sir, we have
Categories of the work.
paddle wheel work,
Mm.
pa- paddle wheel work, and work due to resistant coils
Mm-hmm.
and a piston cylinder work.
Okay. Suppose
Movement of piston cylinder.
there's a ceiling fan in the room,
Okay, sir.
and you consider the fan as a system.
Okay.
How shall you write first law of thermodynamics for him for this system?
Sir, whatever we supply energy is sir, there won't be any internal energy. Uh,
Just write
Sorry.
that in a copy. Just tell me how much is this.
Okay. Sir, if we consider heat transfer as a zero, and work we giving us like electrical work, it crosses the system. It's I square work is equal to I square RT, and it will increase the internal energy of the room.
Hmm. No, but fan is a system
If
here.
okay, sir.
Fan is a system, and you write first law for the fan, not room.
Sir, is first law for Q is equal to W plus U, sir. Q and W, U are zero, and work is equal to I square RT.
Hmm. Are you considering electric work also?
Yes, sir, electric work.
Hmm. What about shaft work?
I haven't considered that, sir.
Okay, now consider room as a system and fan inside this. Tell me how the first law will be
Okay, sir.
different.
Sir, here the internal energy won't change, sir. The same will be there. Like it's if it's a fan, the
Okay, Kishore, how do you define enthalpy?
sir, enthalpy is a thermodynamic property. We can say it's an addition of sum of internal energy plus flow work, sir.
Hmm. And what is flow work?
Flow work, the minimum amount of work we need to give to the flow to flow, sir.
Hmm. Is it a thermodynamic property?
Yes, sir, it's a thermodynamic property.
Okay, but work is not a property. Work is a path function, as you said.
Yes, sir, work is a path function.
So how can you say work is a property?
Yes, sir, actually, it can be any type of work. Like internal energy plus PV is like it. Actually, it's not a work, sir. Like
It is a work or it is not a work.
sir, it's like a pressure difference, sir. Like it's
So
not
can you write
actually a
ideal
work,
gas equation?
sir.
Ideal gas equation. Can you write ideal gas equation?
Oh yes, sir. PV is equal to MRT.
Is this PV same as flow work?
No, sir.
Is it different
No.
or is it flow
Yes, sir.
work?
Yes, sir.
Is the PV, which is the flow work, same as PV is equal to MRT, which you write in ideal gas
No, sir.
equation? Sure. Can we say
Yes,
PV
sir.
is equal to H minus U? H is equal to U plus PV. So PV is
Yes,
H
sir.
minus U, right?
Yes, sir. Yes, sir. H minus U. Yes, sir.
Can I write H as Cp delta T and U as Cv delta T for ideal gas?
Yes, yes, sir. I can. We
And
can
Cp
write.
minus Cv is R.
Yes, sir. R into delta T.
So is it not the same
Yes, sir.
ideal
We
gas
can
equation?
write. Sir, it's the same.
Now for ideal gas, how do you define flow work?
For
I
ideal
mean, what
gas,
is
I couldn't get the
ideal
question.
gas equation? PV is equal to MRT and
Yes, sir.
enthalpy is equal to U plus PV. What is the similarity between the two? Flow work and ideal gas equation.
Sir, enthalpy we define it for an open system.
Is the question clear, Kishore?
Yes, sir. I'm okay.
Hmm. Okay, how do you differentiate ideal gas from the real gas?
Sir, ideal gas we don't consider intermolecular forces, and the volume of a molecules is very negligible compared to the volume of what volume we considered.
Hmm. Okay.
So that we won't consider intermolecular force and volume of the molecules for
Can you write van der Waals
ideal
gas
gas.
equation?
For real gas we consider. Yes, sir,
Hmm.
sure. So P plus A by V square into V minus B is equal to RT.
What is A and B?
Sir, it's a constant for
What is the
intermolecular.
significance? What is the significance
Sir,
of this constant?
actually, sir, if we consider the intermolecular force, there will be addition of pressure, sir, due to intermolecular forces. So we considered A for an intermolecular force, and if we consider the volume, earlier we didn't consider the volume of molecules, so the volume of the container only we considered. But now we consider the volume of the molecule, so the volume should be less than what is actual. So B will match the volume of the molecules. It's a constant.
Okay. Okay, Kishore, let me give the feedback now. So,
Oh,
Kishore, still for ISRO, you have to work a lot. Go for more and more snaps, listen to the snaps. Like, in the beginning, you were confused between latent heat and sensible. So, constant temperature phase transformation के ऊपर heat transaction can take place. Then the flow work actually it is the minimum amount of energy required for fluid to flow. When minimum or maximum comes, it becomes property. Then if you see ideal gas equation, it is the same PV which is there in H minus U, right? So there are a couple of things. So I have asked you basic things for room. When fan is a system, then the energy transfer is like electric work goes inside it and shaft work comes out of it, and the rest is heat interaction because of friction. So that friction is also there, that heat rejection. If fan is a system, if room is a system, then fan becomes part of the room. So electric work goes to the room and internal energy increases of the room. That is for the room. That is how these two things are there. So just revise the marathons, listen to the snaps, and try to work on the questions which I asked you. So he will ask you these kind of questions only, basic,
sir,
small things.
in first case you said like in fan, fan is a system. The shaft electric current is coming as a Q.
And
In
shaft work is
first,
going out.
yes, sir, Q is equal to U plus W. Sir, W is shaft work.
Shaft work, no, there is only W. There are two kind of work here. One is
Okay.
electric work
Okay.
and another is the shaft work.
Okay, so there won't
Electric
be
work is
any
coming to the
U
system,
and
shaft work
Q.
is going out of the system. Plus heat rejection. There
Okay.
is no U in this.
Internal energy there won't. Okay.
Internal energy of a fan is not changing, no. But when the room is
Yes,
a
sir. Yes,
system,
sir.
then electric work goes and room ka internal energy changes.
Okay, so then there won't be any Q. Q will
हाँ,
be there like a heat rejection from the fan.
heat rejection from the fan when fan is a system.
Okay. Oh, in that there won't be any Q. If we consider whole room as a uh,
If we consider whole room as a system, then there is no Q. It is all U,
one. Okay.
right? So
Okay.
work on this, work more, right?
Okay.
So that's what actually, if you want to clear interviews like ISRO, your concept should be really good. Go for more and more snaps, huh?
Okay.